Okay, thank you very much to all presenters. I think we can then start discussion. I encourage all attendees to post their questions either on individual papers or on general topics that they believe are relevant for more than one paper. And I see there are already a couple of questions on Hua. Feel free also to have questions on the chat, please, and on the Zoom chat. And also don't forget, I'm gonna repeat this at the end of the session, but you can also rate this session. I think you can do that in Hua, correct? So if you want to rate the session, please do it. Okay, so while listening, I think we have a sort of two clusters of papers in this session. So we have, I would say, papers 2, 6, and 8. No, sorry, paper 3, 6, and 8. So the risk paper, the real-time travel time estimate, and the last paper we heard about the charging. That, so to say, I would call them look at more large-scale issues with managing traffic and mobility. And then the other papers look a little more in detail, right, in the car and that the driver. So I think we can also, maybe in the discussion, keep in mind that we have these two clusters. The way I would like to do this, maybe I would like to start with some specific questions on the papers, maybe divided in these two clusters, and then I have a couple of topics I would like to discuss more in general. So let me start maybe with the large scale one, so the papers 3, 6, and 8. And I have a question that I think applies both to paper 3 and yeah, I mean, no, mainly to paper 3 that I would like to start with, which is, so you had, so if the authors, of course, then can answer. So you have this system to create a schedule for sensing task, or to schedule the sensing job that allows you then to gain a given performance of a sensing task. So what I was wondering is, how do you, I didn't understand, how do you let the requirements of the specific sensing task go into your system? And if you could make very specific examples of the sensing tasks you have in mind. If the authors of paper 3, that's
risk.
Yeah,
Hello?
risk is yeah. Hello, please go ahead.
No, so your question is to provide an exact example for the sensing task. Yes.
Yes. Could you also
okay.
switch on your video so we can see you? I think.
Yes.
That would be
For
nice.
this, a real there's some real example is they use the bus. The camera on the front of the bus to sense the load on the road to check if some vehicle to check if there is a car stop at the park at the bus station, something like this. This is some sensing task because it uses the camera to sense something and then upload this data to the cloud there, so to check if there is some events. Another case is they can use the camera data to recover the accident. So this is the why we can use use those sensing for some applications.
Okay. And so you can specify in your system then the type of requirements the application has in terms of granularity of the data and so on, and then let that be considered by the algorithm.
Yes.
Okay. I think there is also a question on the chat for CaroSense, which I'm gonna read on Hua. So that's paper number Oh no, sorry. So that's another block. So let me do it later. So a question of for paper 6, the real-time travel time estimate. You are so if I understood it correctly, you are not trying to reconstruct the trajectory of the vehicle, correct? Or are you trying to do that? Because you focus a lot on this travel time estimate. And what I wanted to understand is whether in the end, what are you really predicting? Or you want to predict really one number, which is the travel time, or do you also want to reconstruct more specifically the trajectory of a vehicle?
Yeah. Hello?
Hello?
Uh,
Go ahead.
Pardon? My English is poor.
I think it's perfectly fine. No worries. Take your time.
Pardon your question? My English is poor.
I need to repeat the question. Sorry. You want me to repeat the question?
Yes.
Yeah. So my question is a very basic one. So pardon my my ignorance. Is in your paper you focus on, you say that you focus on the travel time estimate, right? That's an
Yes.
important parameter for many applications. What I wasn't sure about while listening to the presentation is whether you really you want to predict just the travel time, or you also want to reconstruct the more specific trajectory of the vehicle.
We only predict the travel time, and
Okay.
yeah. Uh, 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 we so sorry.
Okay, and then so that's it, the travel time estimate, and then you want to use that for optimizing something at the city level, or you want to use that for the driver, or so what type of other system are you going to feed with this information?
We want to use this travel time to select first line to the destination, and we recommendation the travel like recommendation the trips and charge and
To the driver. So
the main application is that we want to recommendation the trips for users. We want to select shortest travel time
to shorten the travel time for the user, so for the driver.
Yes.
Okay, I see that. Okay. Thank you very much. Another question, so for a fair charge, so the paper number 8, and so you have this charging recommended system for the vehicle. One thing I also was curious about is how do so or maybe I can say the background. So I've seen some work where people try to sort of combine like the like Uber drivers and so on, how they pick up passengers so that they can optimize their travels. So what I was wondering, so how do they also the user somehow get into this system, right, into the fair charge? So if you could elaborate a little bit more on that. So if you right, if you have how does the information about where are users and when do they want maybe to get a cab, right? So if you have also information about that, how do you feed that into your model? So this is Guang Bang, I think.
Yeah. Okay. Yeah, thanks for this question. And
I cannot hear you very well. I don't know if it's only my problem or.
hi, can you hear me?
I hear very not very good. Could you? I don't know if it's
Hi,
only my
can you hear me?
problem. If no, Alex also say you can barely hear. Try again.
Hi, can you hear me?
Now it's better, definitely.
Okay. Thanks for this question. And for how the drivers can involve in our system is that for this work we focus on the electric taxi, and it's also similar to the Uber. And for our system, we first need to know when and where the driver will send the charging request. So it's based on their request. After the driver send the request to us, and then we will fit in our system, and then we can decide where and where which charging station the driver needs to go to get the optimal solution for him or for her. Yeah.
But do you
So
plan to use actual data, actual requests, or also an estimate of future requests?
yes, we use the actual data for our experiments, but we also consider the future demands. We will predict the future demand for each driver, and then we will also use their real time request to do the recommendation.
Very good. Thank you. Thank you very much for clarifying this. So
Yeah,
now let me also for the sake of time to go a little bit to the other cluster of papers, so that focus more on the in-car, you know, on the driver being in the car, and then there were a number of very interesting observations made. I want to ask a general questions to the authors of papers 1, 2, 4, 5, and 7, and I hope I didn't forget any. Should have 8 in total, which is in general. So we see in the first paper we saw the intervention in the car. So the meanwhile, sorry, there is my 3-year-old son that is. Should I take him? Yeah, come on. So my 3-year-old son just woke up, hearing me talking. It's 1 a.m. in the night here, and so I need to hold him so he's quiet. Sorry for that. That's
Of course.
the Zoom. So
cute.
thanks. Yeah, because he's sleeping in the room next to this one, and yeah, he's probably now complaining that I'm. Okay, so but my general question was about, so we have the interventions, right, in the paper Pablo presented, then we looked at the interrotability, then there was the localization in the car, the fatigue detection, the activities, and my general question here, and I'd like maybe all the authors to try to get the answer, what is specific and very specific to driving? Right, I could think, I mean, the haptic intervention, Pablo, I don't know if you can give some more details about how that works. I would be very curious. I was wondering, I mean, I don't know, you know, when you have kids and you start getting nervous or stressed about that, right? Who does sort of I understand you don't have the support, right? But maybe you have your smartphone or your smartwatch or other things that can give you that type of feedback and maybe relieve your stress. And I don't know, I wonder whether that's a technique that you could use for, I don't know, anger management in general, right? Not only in the car. The same applies, I don't know, for the localization in the car, right? That we saw, I mean, in rooms or in other settings, we have those issues too. So I'm just curious to see from your perspective, what is very specific to the driving setting that, you know, then of course influences then the technical solution that you propose?
Well, I can start since I'm number 1 in the list. If you relax too much, you can die in a car. Let's just be very clear. It's as simple as that. You know, if I get you to breathe slowly, can I kill you? So I need to study that very carefully. It is about cars. There's 130 million drivers driving one single car every single day in this country alone to go to work and to come back to work. These are ideal times to help people relax. But relaxing in a car is not trivial because you can really die. Like, this is serious HCI research, right? I mean, it requires that you understand performance and safety and, you know, the cognitive abilities. I can get you to sleep in your chair in the office and it doesn't matter. I cannot do that in a car. It's a very different problem. So it's an optimization problem that requires a different type of thinking. Like, you know, I mean, yes, breathing you can do anywhere and you can relax anywhere. The car is yet another opportunity. As a matter of fact, the commute is actually a great opportunity to relax because it's the moment when people are not busy doing other stuff. And we have already, right now we're having an epidemics of mental health and stress around the world. And there's very few places where you can take a break, and the commute's one of them. But you cannot just get people to breathe. We actually saw that in the autonomous condition in the first paper, not in this one. This one was only with drivers, but the first paper that we published in UbiComp 1 year ago, that the autonomous condition, we got people sleeping in front of the car. And that's very dangerous because if they have to take back, then we have problems. So we're basically studying the car because we believe it's a valuable place to study, and we need to make sure that performance and safety are not affected. So I would say, can you do guided breathing with a chair? Most definitely, and we should do it in your office, in your home, everywhere. But the car is a very special place where you have to study more carefully, you know, how to do this kind of research in a more careful way.
So the tuning is much harder. So you have to be much more careful, as you were saying.
Much more careful. You cannot go down to deep breathing, for example. Deep breathing, which is ideal for stress regulation, is not ideal for the car, in my opinion. It's too dangerous. You will get people's attention too low and too relaxed, and you could really get in an accident. Yeah.
Thank you for that. Does one of the authors of the other papers, I don't know, I was thinking, for example, about the activities also. I think it was paper number 7. I hope I get the numbers right. I cannot read my own writing. Or maybe the fatigue detection, right? So that's that's done with the gaze and so on. So I'm very curious in understanding what are then the specific aspects in the driving setting, right? I see the point, for example, I think the inside paper about the light, right, that's low, and I really love the fact that you're basically misusing an existing sensor to do something else. I think that's so UbiComp, right? Ubiquitous computing, that you take advantage of an existing sensor and you use that for something else. So I really love that. And I was curious to understand also, consider your experience, what's, again, so typical of the driving scenario. And I mean, if you want to put that positively, right, how well could you transfer the knowledge you gain in the driving setting into other settings? So I don't know if other others want to try. Maybe I think all, I mean, localization number 5, 4, 7. I think this question could apply to all these papers.
In general, you know, this is Vivek, and I would like to make a very interesting point here, that why the driver monitoring is very important. There is a very nice trade-off between also about how smart your car is and what is the alert level of the driver. If the car is really dumb, the driver will be super alert. Yeah. But as we start now making the car more and more smarter, you know, moving more towards the goal of autonomous driving, it will still be a lot of time before there will be a car that will be completely drive on its own. Human will still be in the loop. But as the car becomes more and more smarter, they tell you, you know, you are departing the lane, or what is there in the blind spot, or if you are really driving fast and might, you know, bump into the vehicle in front of you. So drivers are becoming smarter, but then that is what is also reducing the requirement for the driver to be alert. And that brings in additional challenge. Because now we have to not only look at the state of the driver, how alert the driver is, because for the conditions where we need the driver's input, that is what the response time is considered. Otherwise, a collision will happen. So the car also needs to know, okay, what are the other issues where now we are creating more problems. And if we want the driver back into the loop, the driver needs to be alert, and then accordingly, we have to also ensure there is enough response time. So this is a very interesting area of, I'll say, upcoming research where people have to work on, not only monitor at, you know, how alert is my driver, but also the state of the driver and when it is a good time to have the right intervention, basically, when you get the driver back into the system. So I completely agree. I mean, with Pablo's point as well, if the driver sleeps, accident happens.
Yes. I think, thank you very much. I think it's a very, very important point, so again, I mean, I love this idea, right, that we have a smart system, but sometimes we have to make the system dumber so that it's actually better for the humans, right? And that's, I think, a very important point of this community, right, that where we put the user always in the focus, right? So we just don't look at how, you know, just make the performance better of your system so that it's smarter and smarter, because you have to consider smarter is not always the best, right? I think also, I mean, there is a parallel you could make for the digital assistant, right? There is this concept of the digital creepiness. So that, let's say that the assistant is just too good in predicting your behavior or guessing what you're doing, you're meeting. And if the system tells you that all, you're gonna, you know, it's just freaking you out and saying, that's too much, right? And I mean, the system is better in the sense that it's better maybe at estimating and doing its job. But in the end, for the user, is not is not doing something good. I think there is a parallel there. Maybe now that I have you on, Vivek, I have you there. So there was a question for your on Bua about your paper, CaroSense. So the question I read it aloud is, how do you make your system robust against non-human occupancy detection in car, for example, a bed or suitcase in one of the seats?
Yeah. So for that, like we ended up doing a lot of evaluations. So we did for like a small paper bags, small bags, and the big boxes as well. So we do see that when we are talking about the big boxes, then there is a good chance of the system to get confused whether it's a human or not. And that is where one of the future work that we target is also to work in the area of object classification, because an object is not going to have any micro movements. While the human activity will lead to some micro movements in those areas, the box will not. And if we can use these minute information, then we can also figure out whether it is an animate object or an inanimate object. So that is what we want to evaluate as a next step, and probably we will basically have an answer to that point. But for the smaller bags or the smaller things, that is not a problem for us, at least in the current version of the paper that you see here.
Okay, but could you, for example, I mean, a small bag could be a small kid, or there you have other things like you have, child seats.
Yeah, so we tried with my 7-year-old twins,
okay.
and so I mean we did not train the system for that, but then we tested the system for that, and the system was on an average fine in finding them out. So the system was able to detect them. But I'm sure if I put if I put your kid there, the system will not detect that. So we have not reached to a point of where we can say, okay, we can use the current CaroSense for using the child left behind application. I think it is far away from that particular point. So, but we were also targeting more about like one of the statistics that we have mentioned in the paper, that if we look at, there are roughly about 800 or more fatalities every year in the US for unbelted rear seat passengers who are 8 years or more. And so that so the application that we have, or the use case that we were targeting, while we show all the 4 seats, technically we need a solution for rear seats, not the front seats. Front seats do have weight sensors and they are not going anywhere, they will stay there. So more we need for the rear seats. Rear seats is an issue because we want to remove all the wires and everything. There are certain cars which are configurable, people take out the seats and remove it, and if you have wires, then every time you have to connect and disconnect, and that creates issues over time. And so that's why a wireless solution is more preferred for the rear seats. And so that is where at the base case, we see that our system is working fine for now. And so there is a real-time demo as well. So we plan to show it to a few OEMs and get their feedback. But the system, I won't say is immediately where it can go to a product right away. So there are still certain things that we have to do to ensure it's a product-ready solution.
Okay, thank you very much. Very, very exhaustive.
So in addition to Vivek's point, so this is Yunzi. So basically, for our current design, so we have a 4D tensor, basically consider the time domain information also in multiple CLRs. When we build these CNN models, we automatically learn the spatial and time domain features. So to answer this question more detailed, like for the current setup, we still can analyze, can extract some time domain feature to differentiate the non-human object and human object, because human object, as you mentioned, always has some small motion like heartbeat, breathing rate, or small motions with your hand or head. And we also evaluate this point in our evaluation session, like we have tested in, for example, a small backpack, a big box, and an empty car seat, and also a water bottle. So in all these stress test scenarios, for this non-human object, we can achieve around 90% accuracy. So in the future, as Vivek mentioned, also like we are currently working on to more classify different type of objects just based on the UW signals in more fine-grained manners. Yeah.
Thank you very much. Thank you. That's very, very exhaustive. Maybe I would like to hear also from papers, for example, 4 about fatigue detection, activities in the car, number 7, and also the interruptibility part. What's your opinion about, what is very specific to the driving scenario, and what do you think is transferable to other, let's say, ubiquitous computing setting or other settings in general? Maybe, I don't know, 1-2 minutes each, and then I have one question that is a general one that I think applies to all papers that I would like to discuss with you.
Yeah.
Let's start
So
with.
hi.
I'd like to add, like Vivek made a very interesting point that, as cars are getting smarter, we are stopping to focus on maybe how smart the system has to be to analyze what the driver is doing, because, transferring all the technology to the car to like take definite actions is, I feel, a bad system idea. So at the same time, we also have to take care about how we make the drivers adapt to the situation around them, and that I feel is important. And at the same time, one key focus area should be to not only like add systems onto the car, but like use smart devices that we have around us. I think that's the idea of ubiquitous computing, or things like, your smartphone is like so smart these days that you can essentially analyze everything about the driver and let them become more smarter about the actions that they take. And I think our idea was very much inspired. Like at MSR, we've been on HAMS, we've been working on like using smartphones to make the driver alert and make the driver more aware about his about whatever is happening in and around the car. And I think one area that specifically lacked was like monitoring using smartphones in low light. And I think um, that's where technologies like using Wi-Fi or wireless to kind of detect activities like really helps. And I was actually wondering if our instead of mounting Wi-Fi devices in the car, if our smartphones could do the same wireless sensing kind of a thing, and not use cameras where it's difficult to mount the camera on the windshield or something like that.
Yeah, I think adding to Ishani's point, right? Today, smartphones are being so widely used. The challenge is how can you use it in low light, right? So there is a lot of work which is still to be done in terms of monitoring in low light. And we believe the technologies, what we have all have been talking about, right, can also be applied to various scenarios like factory monitoring, people monitoring in other places, right, where you exist a similar kind of conditions where there is not a lot of training data available, and the techniques what we have developed here, right, can be easily applied to across various domains. And driving is a way much more challenging domain than others.
Yeah, I really want to echo this. I think, the car is not a trivial place to design for. Like, it's a very hard problem. Like, I think this parsimonious approach of like going for simulators, for closed circuits, and going like into the real world, it matters. And that's why, so many of us use so many sensors and do so much validation. Like, this is very common in health, right? You don't release a drug that goes out into the wild, like, in 2 years, right? Just because you run one single study, right? This revalidation and repurposing and doing a lot of this thing takes a lot of time. And that's actually something that I would really want to like say it out loud. I wish like there's more appreciation for revalidation studies in the community of like HCI in general. I think there's too much emphasis on like, innovation, but sometimes these revalidation studies and these in-depth studies are very important too, especially in a car. Like in a car, you cannot mess up things. So I think the part of the what you will learn from a car is also how to really appreciate the complexity. And that might not translate to other domains directly, but you will learn very much in depth what's going on with those sensors,
Yes.
which you might not learn elsewhere, right?
I would like to also, you say the important word like validation, and I think it's in general, I think as a community, we should put more emphasis in that. We may have the tendency to say, okay, this study or this, this technique has been tried out, this type of data collection, so it's done, it's so to say, go over it. But I think it's important that we give more emphasis to papers that try to redo something or validate results that have been already achieved, because once we get critical mass, we can really then trust those results, right? Or learn more, just right. If we do so, I think as a community we probably should put more emphasis in also in validating existing results. I see a couple of questions on Hua. I would like to ask the people that the question has been is posed to answer, but in a short time, so we still have a few minutes of time for the longer discussion later. The little one needs to go to bed. So there is a question for RF-based activity recognition inside automobiles. I think that was number 7, correct? So the question is, RF-based activity recognition inside automobiles looks very interesting. Did the authors of these papers notice any noise generated by adjacent vehicles or nearby vehicles?
Yeah, that's a very good question, because it's a general concern that the object outside the vehicle can affect the CSI signal inside the car. But this is actually our second paper on this topic. On the first paper, we have tested the scenario that whether the object outside the vehicle can affect the CSI signal inside the car. So the results show that the spectrum we collected is not very different when we do the experiment in a parking lot, when we park the vehicle and do the experiment in that car. So I think the reason is that because the distance between the outside object and the driver to the devices, to the Wi-Fi devices, especially for the receiver, is much closer for the driver. So the reflection from outside is not very, the signal from that path, from that reflection path is not very strong, so that it can be neglected. This is the first reason. And the second reason is that the car body is made of metal. It's a kind of a reflector. It's like a mirror to the radio wave. So so due to these two reasons, we can assume, or we can to some extent neglect the effect from the outside body, from the object from the outside body. And we also have a driving test in our paper, but due to the time limit and constraint, we didn't present the result in our presentation. But the results show that it just slightly decreased to the recognition accuracy. So I think that's all for the question.
Okay, thank you very much. There is a question also, to me goes in a similar direction, but I want to read that aloud from Hua. Most of the behavioral and health-based works focused in cars, like paper 1 and paper 2, for example, consider real-life driving in constrained scenarios, like predetermined circuits. Do you expect a behavior shift in unconstrained environment when drivers use their own vehicles? So if you do, go ahead.
Yes, so sorry, I didn't quite understand the question well. So can you repeat
so
that?
The question is that when you most of the work, or many of the papers have been presented consider real life driving, but the scenario is constrained. You may have, I don't know, a predetermined circuit that you drive, and so the question is whether you expect any shift in behavior in the drivers, I assume, when the environment is really unconstrained, when you're on the on the real roads, in a real setting, in a real commute, whether you expect any effects there.
So you're talking about the different environment, or like how different environment can affect the performance or work, right? Just want to confirm that.
Yeah, so, I think it's more question maybe for papers 1 and 2. I don't know if Pablo or Auk
in terms of the inside paper, right? So on our driver fatigue papers, what we have done is we have clearly seen that when we ask drivers to drive in a basement or in some specified circuits, right, they are very much more cautious than driving in real world conditions. So most of our evaluation has been on real roads when they drive freely without with passengers and when they are on their duty, right? So we see a real characteristic change when they drive in basement versus real road. So yes, and that's very important to be considerate of.
Yeah, for us it's very complicated. Like, we cannot just stress people up. We're inducing a stress with a stressor. We're already increasing arousal, putting a person in a dangerous position, and then we lower breathing considerably. That messes with your cognition. So we cannot go to the road. We started with the simulator to see if they can do it first, if we didn't get a lot of accidents. Then we did it on a closed circuit on the garage that I showed you. And then now we think that we can go to the streets. Like, we feel like it's the time to maybe do a third study. But you know, the performance and safety is important. Actually, Matt, my postdoc is here. Like he did some of the analysis of the performance. I don't know if you want to say something about performance, Matt.
Yeah, I mean, as far as people in our study, performance wasn't really affected by the intervention itself, though those should probably be continued to be tracked. We didn't notice any, severe lane departures. There were mild departures in both conditions, and those were stable across the intervention and control groups. So I think that's important to continue to measure these things and continue to evaluate safety as we try to move from a sort of controlled garage to on the road context, and that'll be very important to continue to monitor.
I see. So I think bottom line is, I mean, also depending on the specific study you're doing, you may do some tests on real roads, or you may not, or you need to wait some other results first.
Yeah, I don't know if IRB will approve like doing stress in a car without knowing what's the effect of stress in a driver. Like maybe in some universities, but not in ours.
No, I think it would be hard in I mean, most ways. So I do want to take a few minutes because to put one question, there wasn't who I also had that and so on, which is a very general one, and that is been mentioned. So what about autonomous driving? How does that change the game, right?
Yeah.
And so what's your, I mean, would you say, well, if autonomous driving is really, comes really, and in 2 years is there, then your work is useless? Or do you think that also in autonomous driving, you have a lot of things, left to say? So let's, maybe all the others can participate. Let's maybe afford a few minutes of delay on the end of the session, if Alex allows that, and discuss this.
Yeah, I
Pablo,
think
you want to
that
start?
autonomous driving thing, right, is interesting. I think autonomous driving is going to come for sure, right, in the next 5 to 10 years. But in which regions, right? So in the US, yes, in the 5-10 years, but in developing countries, right, it could be next 10 to 15 years. And irrespective, right, drivers are not going to go away. So drivers will be always there, because even a completely automated vehicle would still have to give back the control to driver at some point of time. So all the work what the entire community is doing on monitoring the state of the driver, right, is completely complementary. Today we might be doing to make him alert and ensure that he's driving safely. But in the autonomous world, right, it would be if the vehicle gives back the control, is the driver in the right state to take it back? Right. So all the work what we are doing, I think across the community, I think it's still relevant even when autonomous vehicles comes in.
It's actually extremely relevant. I mean, I completely echo what Akshay is saying. Like it's not just the control of the taking back the owner. Autonomous driving is going to happen slowly, right? So what's going to happen is that the human drivers are start behaving like assholes to the autonomous cars and trying to be mean to that. And we need to control those drivers, and we need to understand what those drivers are doing. That's actually in every simulation of autonomous driving, the problem is the human driver, right? That's the one that messes up with the traffic. If you remove all the human drivers and just put autonomous drivers, then everything flows perfectly. It's the human driver that messes up. So human driving, controlling and understanding the human driver will become the most important thing for autonomous driving in the future. More important than the actual autonomous driving part. It will be like, how do we control these humans, right? That's what's going to happen. Yeah.
How do we avoid them messing up with the with the perfect system?
Yeah, I think to add on to what Paulo mentioned is that because we're talking about toward the autonomous vehicle, what's going to happen is that nowadays we have people doing the multitasking, and then toward the autonomous vehicle more and more, then I think that people are doing the more multitasking. So in that sense, using the sensors to better understand what's going on inside vehicles to exactly profile some of the potential outcomes and monitoring cognitive state so that if emergency situation happens, then we can readily take over the situation so that people can do the engagement. So I think that in that sense that even though we're actually moving toward the autonomous vehicle, understanding vehicle situations, understanding the cognitive states of the driver is also still relevant. Right.
Anyone else wants to add something of the authors?
I would only like to add, one point now, especially I will put a disclaimer. But then while there is a lot of talks, about automated driving, a lot of work being done in that area, we also see some applications coming around. But if we talk about a fully automated car, it is going to be many, many, many years further. So in the future, we will see more and more smarter cars. I mean, doing maybe many of the applications that current automated cars are also supporting, with maybe more sensors around, providing users with much more information. But a fully automated car is not anywhere near the horizon.
I mean, I don't know if maybe that's too trivial, but I guess there will be also very strong geographical differences right there. I don't know, I'm originally from Rome, Italy, and I could imagine the traffic situation there and just the geography there is very different than, I don't know, some cities in the US, right? So I could imagine that, I mean, there are some things that are there since thousands of years, right, that you cannot change in a few years, even if your technology is great, right? I mean, not even talking about the driving style of but it's really just the structures that you have.
Exactly. So for platooning applications or for really specific applications where the whole let's say track is already marked, and those things where you do not expect a lot of humans coming around or a lot of other cars around, as Pablo mentioned, with the different drivers going around. So when you take those things out, yes, it works. I mean, we see all the time here, every single company around is trying and experimenting with the cars, with autonomous cars, all running around, collecting a lot of data and everything. Another big problem is, like, every time your sensor system and everything is advanced, your original, the old collected data is not that useful. So you have to go through that exercise too. So there are advances and other things are happening, but at least for the next foreseeable future, you can at least say 5 years. Maybe in the next 10 years, you might see more, but at least for the next 10 years, it will become more and more important to actually identify what are the needs of the driver and how to get the driver and the smart car work together.
So if I can summarize a little bit this discussion also, so for the sake of time is, sorry. Vivek, we don't hear you well. It looks like you have some connection issues.
People want to go for smart cars to reduce the number of accidents and also to provide,
Okay, sorry, I think we had just some connection issues. I want to just briefly.
Never mind. I think I was done with making that statement. So I was only saying that yes, for all the research and everything.
Oops, I think we have some connection issues. Let me just. I would like to summarize the discussion. So about the autonomous driving, right? That's a question I guess you guys probably working in this area are getting over and over again. I can allow me to summarize that in 2 points. So there are 2 points. First of all, yeah, even if autonomous driving is coming full speed in a few years, it's going to still be very important to monitor the driver because the driver is not going to be away. And as Pablo also stated very clearly, actually the driver is the one who's going to mess up. And so it's even more important to monitor the driver. And then there is the other point that, yeah, maybe in some places autonomous driving is coming fast or in some setting, but it's going to take a long time before autonomous driving is a reality for the majority of cars, so to say, or of traffic situations. I hope I summarized correctly what has been said. I think it's time probably to close the session also because we are over time. I have to remember you that there are now activities in Gather Town. I think I heard there is even a karaoke session. There is something happening on the beach. I think, I don't know, for me it's mean, right? We cannot be real on the beach, but at least you can look at the nice pictures.
Okay.
So I don't know, what about you guys? I really enjoyed in Gather Town, the activities in Gather Town, so I hope you have time to go there. I think for me and for the little one it's time to go to bed. Thank you very much, guys, for you the authors for the amazing papers and the amazing presentations and for the discussion. And well, I hope to see you around the latest and tomorrow for the town hall meeting.
Thank you, Sylvia. Thank you so much for being up so late, and thank you to your little one also for putting up with us there.
Thank you, guys. Bye-bye.
Right. Thank you.
Enjoy the
conference. Thank you very much. Thank you for sharing.
Thank you so much. Yes.